This short film is made to demonstrate the work of automated system for measurement of geometrical parameters of welded pipes. This system measures parameters of pipes with diameter from 426 mm to 1420 mm. The system work is based on triangulation method of detection the distances with use of laser sensors. One of the sensors operation you can see on the screen. The key point of the sensor work is that the sensor beam spread in line is reflected from the measured surface and is focused on the sensor-sensitive matrix. And the sensor processor calculates the distance to each point of laser line. Thus is calculated the geometrical profile of the object on which comes the laser beam. At the moment we can see that the laser beam comes on hand and the coordinates are shown at the monitor screen. In the system, the laser sensors are located on 3 precision manipulators. The system allows to measure the following parameters: weld measurement, left and right pipe ends, including diameter, pipe end roundness, bevel angle, wall thickness of the pipe, bevel dulling and cutting angle, pipe body, roundness and pipe diameter intersection, general pipe warping per 1 meter, and pipe length. In this case, you can see the work of the system to measure the weld. With the system, we can measure weld height, weld width, pipe profile deviation from the roundness at the length of 200 mm, displacement of welded edges. These parameters are measured by 2 sensors, whose laser beams are seen at the screen. One sensor works with the red laser, second with blue one. Before, of course, the sensors were calibrated and set in one coordination system. Let us see the example of receiving the data from laser sensors of weld measurement. On the screen it's underlined 2 ranges of sensor measurement and shown the data from the sensors. Here we see the work of 2 sensors which consider the weld, and you can see the circle with diameter of 530 mm which corresponds to the inspected pipe. We can see 2 lines at which are calculated the weld parameters. One line, small circle, corresponds to the pipe diameter. Second line is made for the highest point of the weld. It defines the weld height, and 2 yellow lines define the weld width. It is made the constant calculation of all the parameters. It is constantly measured the weld width, height, bevel's displacement. The measurements are made continuously at pipe movement with step about 5 mm. The fluctuation of these measurements, which we see on the screen, correspond to the pipe passing through the roller track and connected with the pipe displacement. At the measurement is clearly seen the weld profile, even if the pipe is moving. All the captured parameters are shown on the screen. On the screen we see the parameters of the pipe. On the next screen we see the inspection protocols on the top. On the bottom we see in detail all the parameters of each inspection protocol. On the right column we see red box corresponding to bad parameters, and the green boxes correspond to the good parameters. Let's go in detail and check weld height along the whole length of the pipe. We can see the 2 red horizontal lines. The red lines represent the tolerances. The laser measurements are in blue color. On the right we see the statistics of the inspection. In the next screen we see the deviation from the profile. Each spike represents the step of the press. The measured points are shown in blue. We can see that they exceed the allowed tolerances which are caused by pipe bending. It is possible to study in detail, for example, the deviation of pipe surface profile from the pipe. Now we will see the example of inspection of pipe end parameters. For this purpose, the pipe is automatically positioned in the place of roller track, where is made the inspection. The pipe is lifted on elevating lifting rollers. Manipulator puts down the laser sensors. The laser sensors which are located beneath the pipe are protected from the penetration of foreign objects and dust by special screens, which are open automatically by sensors operation. After positioning the pipe and the sensors in the inspection position, the pipe is rotated and sensors scan the pipe and along the whole perimeter. In this way we measure the following parameters: bevel angle and bevel dulling of pipe, wall thickness, diameter, roundness and cutting angle of pipe end. At the same time as measured pipe end parameters, the measurement of diameter and pipe body roundness and total pipe warping. After the pipe has performed the full turn, the measurements finish, manipulator raises in initial position, the pipe goes down at turning rollers. In the same way as for the weld, are calculated the other parameters: wall thickness, bevel angle, cutting angle. Bevel angle is defined automatically. Here you can see all the parameters. In the next graph is made the measurements of left part of pipe diameter. Below is the measurement of diameter in middle of the pipe. Now let's see the measurements of wall thickness. The wall is thick enough, about 45 mm. When the press bends the pipe, the wall is suppressed and the pipe becomes thinner in the places of pressing. Here you can see the difference of wall thickness, about 0.3 mm in this case. This was a short demonstration of the automated system for measurement of pipe parameters. Thank you for your attention. If you have any further questions, please contact LOCUS.